Hi, welcome you all. So I am Dr.P.Ezhumalai, Professor and Department of CSE, R.M.D.E.C College, Chennai. So in this lecture, we are going to see theory of computation. In that part, the pumping lemma theorem. We are going to take one example to prove that the given language is not regular. According to the pumping lemma theorem, so we are going to solve that. Listen. So prove that the language a power n, where n equal to I square, the I greater than equal to 1 is not regular. That problem you have to going to prove. So for that, so these are our assumption steps. In step 1, initially we are taking this language is regular. Assume that the language L is regular. Then step 2, the number of states in this given language is a power n, where n equal to I square. So the maximum power number of states in this language is n. Then step 3, we take any string w. We are assuming this given string is w. According to the pumping lemma, the given string is w, where the w is a power n. Where n is equal to I square, the length of the string is modulus of w equal to n. The length of the string is w equal to n. Then step 4, w should be greater than or equal to number of states. Therefore, the length of the string equal to n, it should be greater than or equal to n, where we can break this given string into 3 substrings according to the pumping lemma theorem. So the step 5, we are taking the given language is w. The given language is a power n. The a power n we are going to divide into 3 substrings. Condition of the pumping lemma, 3 strings. I am going to take these 3 strings w equal to x, y, z. This length we are going to find out now. Now the xy we are assuming the length is a power n. The z, the y I am going to find out according to the pumping lemma. The xy length should be less than or equal to n. Y should not be empty. So the xy length is, we are taking assumption a power m. The y length is I am going to take a power j. Then z length we are going to find out w divided by xy equal to z. W divided by xy equal to z. So w you know what is the length is a power n. Okay, w equal to a power n. Then according to that, w divided by xy. W equal to a power n is given here. So xy is a power m. So the z length is a power n minus m. A power n, here is a divided by subtraction by a power n minus m. So this is the length for z. Our assumption, to check the assumption, xy z equal to a power m, then xy equal to a power m, then z length is a power n minus m. So the total, so this n, this m will be cancelled, plus and minus. So total length will be getting as a power n. So our assumption is correct according to the pumping lemma theorem. Then we are going to check the examples. According to the pumping lemma theorem, it should be satisfied 3 conditions. The xy modulus length should be less than or equal to n. In this example, xy length is a power m, less than or equal to n. So m is less than or equal to n. The condition 1 is true. And condition 2, y should not be empty. The pumping lemma says 3 conditions should be true. Y should not be empty. Y length not equal to epsilon, not to be empty. So here y length greater than should be 1. Not empty means greater than should be 1. So our y length is a power j. The condition is given y power j. So a power j is greater than or equal to 1. So condition 2 also it satisfies. Then the condition 3, xy power k, z also it will be true for k greater than or equal to 0. So the above 2 conditions are true. Now the third condition, condition 3, x y power k z equal, the condition 3, y k power greater than or equal to 0, it should be satisfied for all conditions. X y power k z should be satisfied for all k greater than or equal to 0. So this y should be factorization taking like this, x y minus k minus 1. The y will be factorized like this, x y y power k minus 1 followed by z. Now xy length is that is called a power m. Okay, y length that is called a power j. Already is given a power j. So a power j is given. Y length is a power j. So another y power k minus 1. Another a power j k minus 1 is given. Y length. Then z length already find out. Z length is a power minus m. So you summarize of this length, you get a power m, a power j k minus 1 followed by a power n minus 1. This is x, y, and z. So this is the length of this given string, your assumption. Now initially we are going to check three conditions. Now initially we are going to put k equal to 0. So x, y power k, z, k equal to 0. So put the where the k is getting here. So put the k value equal to 0. This is x, y, a power m, and y length is a power j, k minus 1, k put 0, 0 minus 1, and z length is a power n minus 1. So this gives a power m minus j, 0 minus 1 minus is the multiplication of j, a minus j, a power minus j, and then followed by a power n minus m. So this result will summarize a power m minus j followed by plus n minus m. This m and n will be cancelled. So a power minus j plus n. So this will be rewrite as a power n minus j is not equal to n. So it is not equal to original length, which is called a power n. So now put the condition 2, put k equal to 1. So x, y power 1, z, x, y equal to a power m, and y equal to a power j, k minus 1. So the k value equal to 1, 1 minus 1, the z value equal to a power n minus 1. Now this result will give a power m, this 1 minus 1, 0, multiplication of j with mean j also getting 0, so a power 0, followed by a power n minus 1. So this result will give us a power m plus n minus m. Here also m and a minus m will be cancelled. We are getting a power n. So this is getting equal to our original result. When the k equal to value getting original result, k equal to 0 is not giving original result. Now one more value you are going to check. Put k equal to 2. X, y power k, k value equal to z, x, y equal to a power m, and y equal to a power j, k value equal to 2 minus 1, followed by z value a power n minus m. So a power m, this a power m, this a power j 2 minus 1, 2 minus 1 is minus 1, a power j 2 minus 1 is 1. So multiplication of j, a power j will be getting there, followed by z, a power n minus m. This will be summarized as a power m followed by plus j followed by plus n followed by minus m. So this also minimize m and minus m will be cancelled, a power j plus n. So this is also not equal to the original one. Now we can assume, since the value k equal to 0, k equal to 2, we have the string that does not belong to the language here. So this is result will getting not equal to a power n. K equal to result is not equal to a power n. So the language a power n, n equal to I power 2, where I greater than equal to 1 is not regular. Thank you for watching this video. Thank you very much.